Welcome. In this lecture I'm going to talk about the standard libraries that you automatically get access to along with the Java language. We sometimes talk about an application programming interface, and by that we mean the interface between the user of the code, the writer of the code, and the implementation itself. And the idea of having an API, which is to say a defined interface between the person who's writing the code at the moment and the people who have implemented the code that they're using, is that we can change the underlying implementation, if we wish, without affecting the user on the other side of the API. In other words, we insert a narrow contract, if you like, between a person writing a program that uses a library function and a person providing the library function, such that either side can change the part they're responsible for without affecting the other party on the other side of the API. We've already seen, of course, some of the functionality that is often used by many programs. You've seen, for example, how to do printing to the console with system.out.println. We've seen how Java manages strings using something which, as we said, is not a basic data type, but which is actually a very important built-in class, string. You've seen how to generate a random number using that static method parseInt from the integer class, and so on and so on. In other words, in Java and in every modern programming language, there's a standard library, a collection of classes which are available as an ordinary part of the language, available to anybody who writes a program in the language. And in Java, we sometimes call that the Java API, or by abuse of terminology, we sometimes call it the Java documentation, and there's one URL for it. This slide talks about this being the case for every programming language, but actually when I first started working as a professional developer, it wasn't yet established as a normal thing that would happen with every programming language. When I was programming first professionally in C++, one of the things that the organisation I worked for had to do was to choose a class library to use with our C++ programs, because at that time, it's different now, there wasn't a standard library of C++ classes. This is a tremendously useful thing to have, though, and it's reasonable to assume from now on that this will happen with every programming language that you meet. So how are such classes organised? They're organised into packages. We've seen already that things that need to be changed together should live together in order to make it reasonably efficient and easy to maintain the code when necessary. But the level of organisation which we've already seen, organising things together into classes, is not enough, it turns out. We have way too many classes to be able to do without any other level of organisation. So we need a way of organising code on a higher level, organising classes that are related together. And in Java we do this using packages. And you can think about these as subfolders or subdirectories in your operating system file hierarchy, and usually they are in fact laid out in a way which corresponds closely to that. So in Java we have, for example, the package whose name is java.lang, and that contains the fundamental classes for using the language, the things you've already met, such as integer, math and string. I don't think it is maths with an S, actually, is it? That's very British. We also find java.util, which contains, as you might guess, various utility classes. Arrays, with the S there, gives you various useful static methods for doing things with arrays, for example, and we've seen date in passing, I think, and scanner, and so on. Notice the naming convention. Naming conventions are very important in Java. Here, package names always start with lowercase, unlike class names, which always start with uppercase. And we say sub-packages separated by dot. Actually, it's a curiosity of the way that packages in Java technically work, that actually the use of dot there is really a convention. There's a sense in which java.lang is just a string, which is the name of that particular package, and the fact that it's separated into two parts with a dot isn't quite as significant as you might expect, but I'll leave you to look up the details of that if you're interested. So how do you use classes from a package in your code? Well, you have to specify which class from which package it is that you're referring to. There could be more than one date class available to you, and so you need something to say that the one you mean is the one which is contained in the package java.util. And so you get code like this. You can write java.util.date today equals new java.util.date. That's the most basic way of writing code to use a class from one of the standard packages in the Java JDK. That's a bit tedious, and so to save you some writing work, you can import the necessary classes. And what that tells you is that you can skip the package prefix, because what you're doing is you're saying, within this program that I'm writing, within this class that I'm writing, I want the names which are declared inside this class java.util.date to be available to me to use without my needing to specify the package prefix. And so we get to write the more simple version, date today equals new date. Notice where we put the import statement. It has to be outside the class definition. It is possible to import all classes from a package using that star notation as you see at the bottom, but this is often considered bad practice. Why? Because it makes it more difficult to track down what the dependencies are within a large system. The version where we say import java.util.date tells the reader of this program that this code depends on that class and on no other. If we had instead imported java.util star, then we would have known much less about what the dependencies were, and so if, for example, we got a notification that some other class in java.util had changed, we might have had to check this class carefully in order to see whether that change affected this code. Whereas if we know that the class we're depending on is java.util.date and not java.util, whatever the changed class is, then we can see immediately that we don't need to check for that, and that saves us effort. So it's always better to be precise about what you depend on and import just the classes that you actually need. Sometimes it's useful to be able to import just the static methods and static constants from a class. So here is a piece of code without demonstrating the static import feature. You see that if we want to use features like calendar.year, which is a constant defined in class calendar, we still have to refer to it using the class name. We don't have to write java.util calendar year, but we do have to write calendar.year. Here's a way of saving even more effort. We can import static java.util calendar.star this time, and that says what we want to do is to import all of the static constants and methods from that class, java.util calendar. And in this case it is quite common to use the star, because if you want to be able to refer to one static constant, you're most likely to want to be able to refer to all of them. I think at this stage, as beginning Java programmers, you're more likely to want to recognize this kind of import rather than actually use it. But there it is, if you do want to know about it. Now, one thing you may be wondering, how come we haven't had to use importing packages before? After all, you've written plenty of programs by now which use the packages integer, string and math, but you didn't need to import anything. Why was that? Well, the reason was that those classes live in the java.lang package, and those ones are automatically made available to you in every Java program. So that's how to use packages. What happens when you want to create your own package? Well, you just need to use the package keyword. So the package definition goes in the first line of your class document, your Java file. You should make sure that that you put the underlying file in the correct subfolder. So if, for example, your class state printer is declared to be in the package com.dateapp.output, then you're going to want it to appear in a directory com/dateapp/output, and then within that directory in the file dateprinter.java. And normally your IDE, if you're using one, will enforce that anyway. So this is the kind of thing that you might see in an IDE. You'll get shown the file hierarchy and the Java classes within that hierarchy. When you have classes which are in the default package, that simply indicates that you haven't put a package statement in them. And that's the kind of thing that you will typically do as a beginning Java programmer, but typically not do as a professional Java programmer. Now, in some cases in Inf1B, we may instruct you to put your classes in the default package, in other words, not to include a package specifier, partly because that makes it easier to test them automatically. A large part of the point of packages is that they maintain their own isolated namespaces. In other words, you can have classes with the same name, and those classes can coexist even in the same program, provided that they're in different packages. So very similar to the ideas that you're already familiar with in file systems in an operating system. You can't have two files called foo.txt in the same directory, but you can have two files called foo.txt if they live in different directories. Very similar for Java. So now let's have another quick look at the API, and we could visit that URL if we wanted to. But for now, all I'm going to do is I'm going to show you a short example of strings from the class library, because it's quite useful to say a little bit more about strings. We've been using them without saying very much about them at the moment. This particular extract from the string API comes from Java 8, but I don't think it's changed very much since then. It's just an old slide. So the underlying set of values of strings is sequences of Unicode characters. One of the most important things to notice, which sometimes confuses people, is that in Java, strings are immutable, in that none of the operations, none of the instance methods that you can call on a string object, actually changes the value of the underlying string. Well, what do we mean by that? Let's look, for example, at the concat method. So that's the third item in this list here. So if you send the concat method to a string object containing giving another string as argument, so we might, for example, write s.concat t, what we're trying to say there is the string that I'm interested in from now on is s concatenated with t. Okay? So you might expect that the result of sending the concat message to that string s would be to change the value of string s so that it was its previous value with t appended. However, because strings are immutable in Java, that's not actually what happens. What happens is that the receiving string object isn't changed because it's immutable, and instead the return value of that method is another string. You can see that the return value is string there in the API, and the string which is returned has the value which is the original string with the argument string concatenated. Okay? Now this is quite often convenient. You might also wonder about efficiency, and if you're wondering about efficiency, you'd be correct, and one of the things that you will quite quickly learn if you start programming seriously in Java is that if you want to build up long strings, then partly because of this kind of issue, you should probably be using the class string builder to do so rather than the class string. But that's a slightly more advanced topic which we won't say much more about right now. What else do I want to say about this list of things you can do with strings? Well, not a lot really. You can create one, you can index into it and find the character at a particular index. We talked about concatenation already. We can compare two strings. You might ask yourself, why does that return an int rather than a boolean? And you should look that up. I think you'll find that's because there might be a less than, equal or greater than issue there. You can check various things about what strings end with and start with. You can find substrings, and so on and so on. But the point is that you can always look up the details of what these things do in the Java API there, and I encourage you to pause this video at this point and go and have a look. Are you back with me? Let's now look at some typical string processing code. These things, by the way, are pasted in as pictures, and that means, I remember being annoyed by this long ago, that we have one tiny annoyance in that top example. Can you see what it is, I wonder? It's the fact that we've got int n and it's a capital N. It should be, according to the Java conventions, it should be a lowercase n, because it's not any kind of final constant. It's just a perfectly ordinary local variable, and local variables should have names beginning with lowercase letters in Java, so I do apologise for that, but it gives me a chance to point it out and just make sure that you know this thing. So we've got a piece of code at the top there which is going to take a string as argument and is going to calculate a boolean to tell us whether or not the string is a palindrome. And if you have a look at it, you can work out how it works. We're going to first of all take the length of the string. You can always find the length of a string by sending the string the length message, which will return you an integer. And then we're going to iterate halfway through the string, and we're going to check that each character is the same character as the character in the mirror image position starting from the end of the string. If we find at any point that it isn't, we're going to give up and return false. And if we get to having checked the whole string, and without finding an error, we're going to return true. What else is there to say? I don't think there's a lot I want to say about this actually. I think I just want you to have a look at it. You might wonder about that studin.isEmpty there. That is not really something to worry about. It is just a convenience API that comes out of a particular library which I don't think we use so much these days. Okay. Sometimes you want more fine-grained control over print strings because just using ordinary println can be a bit clunky. So suppose what we want to produce is something like the student named Lee is aged 18, where we have the name and the age in variables, and so we want to put them together with some boilerplate text to produce the appropriate output. Well, you know how to do it using something like this code, but that's not very nice. What we'd like more is to have something that lets us build up a string with some gaps and then just specify separately what should go in the gaps. And that's what Format Specifiers let us do. So it's slightly weird, and I always have to look it up each time I use it, and you shouldn't worry if you have to too for a bit, because we get these funny percent placeholder markers. So this string is a string with placeholders, and basically it says the string named, there's going to be a string here, %s indicates this is going to be a gap that's filled in with a thing of type string, is aged, and there's going to be another string there. Why a string? Because we're going to turn that age into a string in order to print it, really. So those things are called format specifiers, and each format specifier is going to get replaced by an actual value, and here is how you do it. String.format returns a string having done that plugging in. So this we're going to say here is the string with the format specifiers, and then we give the values that we want put in place of those format specifiers, name and age in this case. And here's how you'd use that in a program, and there's what you get as an output. So you should play around with this. I think there are some examples in the lab sessions. We don't have to produce the string and then print it with println. We can use printf. This is a hangover from C. The standard C printing feature used printf and used format specifiers very much like this, and that's really why they're in Java, I think, despite maybe looking a bit clunky. It's because many of the first Java programmers were C programmers by origin, and they were already used to this, and so Java included it too. You can do a bunch of other stuff. You can have characters rather than strings, and that will just work. We can use floating point numbers and integers and various kinds of things. So you should expect to have to look this up. So the main thing to do is to know how to look it up in your book or in the JDK, however you like. So math.py is a floating point number, and we can use the %f format specifier to say what's going to go here is a floating point number. OK, Java, please print floating point numbers the way you expect normally to do. Or we can give more information about how we want the floating point number to be represented and possibly approximated. So that .2 says that we would like 2 decimal places, please. Okay? And there's a lot of flexibility in exactly how you do it. So don't memorize this, as I say, know how to look it up. Some things that you may have come across in other languages, maybe in Haskell previously, \n is a new line, and there's various other options here like \t as a tab character and so on. And that can also be quite handy. Now, what about documentation? What about when you are? So you've probably already started to appreciate the importance of documentation in the standard libraries when you want to understand how the standard libraries work. What about when you're writing code for real and you want to document your own code? Well, it is essential to be able to do this for a whole number of reasons. Obviously, if you're writing code that other developers need to be able to use, then you have to give them enough information to let them understand how to do that. It can help you to understand, it says here, understand the workings of a complex algorithm more quickly. It doesn't really matter there whether you're writing it or whether somebody else wrote it and you're reading it. Often thinking about how to explain it is a very useful thing to do to help anybody reading the code understand what's going on. You might feel as though if nobody but you is ever going to use your code, then there's no real need to document it. At some point you probably will have to write some code and then come back to it a few months later, and just trust me on this, you will be surprised how quickly you forget what was in your head when you wrote the code. And so documenting your own code can definitely save you hassle later on. Quite often though, the process of working out how you would document your code is useful in another way because it helps you to understand what's wrong with your code. And so quite often thinking, that's a bit of a peculiarity about my code, maybe I should document it, actually leads you on to saying, well, instead of documenting this peculiarity, why don't I just write the code better in the first place? And that's often a better thing to do. So what do we mean by documentation? Well, you can have some comments inside the code. This is a rather artificial example whose main purpose is to demonstrate the syntax of two different kinds of comments that you can put in Java code. So at the top, with the /* some writing // you see a multi-line comment. So that one, in that case, the comment proceeds from the beginning pair of characters until it meets the end pair of characters, even if it goes over multiple lines. That's relatively unusual to see as comment syntax in Java code because it turns out that particularly in these days where IDEs support what you're doing, it's actually more convenient because it's clearer to have a comment character set starting every line that is supposed to be a comment, as you see in the second example there where // says everything on the rest of this line is comment. Of course, the effect of a comment is not only to alert human readers to the fact that they maybe might want to read this, but to alert the compiler that it should be completely ignoring this stuff. The compiler discards comments and does not attempt to read the code on them. Okay. There's a particular formalized kind of documentation called Javadoc, which is convenient in the sense that if you write comments in the particular way that Javadoc lays out and expects, then you can use the Javadoc tool in order to automatically generate nice HTML documentation. And this is how the JDK documentation is generated. If you go and look in the actual source code of the JDK, you see that its documentation is present in the source code as Javadoc comments. The nice thing, of course, about putting the documentation in the same file with the code is that it makes it much easier to make sure that the documentation is kept up to date with the code when the code is changed. So what do we see here? We see that a Javadoc piece of documentation for a class will start with a summary sentence. You can use HTML features in it because it's going to get turned into HTML eventually anyway, and there are some standard tags. For example, the @author followed by an author name will tell you who wrote the code, and that will get placed in the documentation in the appropriate way. And again, you can look up the details of exactly what is available in Javadoc, and you probably will want to do this when you're writing your coursework. Other things that are useful to know, here's an example of a Javadoc section coming before a method. So in this case we're using the standard tags here, param, return and throws, to explain respectively what the parameters to the method are, what the method is promising to return, and what exceptions might get thrown and under what circumstances. And that basically just says the same thing again. And there's a URL there where you can find some more information. And now we'll see a quick demo of using the actual Javadoc tool itself.